Thank you very much. I think you've stolen my introducing words.
Sorry.
So I have to just think for a minute. But I just want to reflect on what Andrew said earlier, doing more with less. That's a really important part of what I hope I'll demonstrate. And David was talking about helps us answer questions. And in the world in which I work, it's about helping us solve problems. So it is a slightly different perspective, and I hope you shall find what I have to say of interest. So I am definitely an advocate, not an expert in this world. And I put up this photograph because, one, we are here in Westminster, and this is probably the most complex project I have ever worked on. Why was it complex? It was in a historic site, very constrained for deliveries, and we could only get in 4 lorries a day. Every element of this building was prefabricated and brought to site, ready to assemble. So the construction methodology was also unusual, so we were learning for the first time. And what was the world that we were in? So like David, I'm reflecting on my career. For the first 15 years of my career, I worked at a drawing board with these tools that you see on the left. And it wasn't until about midway through my career when I was working on Portcullis House when email arrived. Electronic project systems arrived. So that building you saw there was designed on paper in every element of it. There was some analysis done, but it was essentially a physical process which we went through. But the tools have changed over that time. 3D models came, we got computers at our desks, we're using the cloud now. And I think in the world that I work in now, everybody works in front of models with multiple screens, imagining the future and imagining what problems they're solving, how they might solve them, and what we might create. The output, I think I've described that. It has gone from very paper-based to now, through the modeling, 3D, 4D modeling, to now we model in the center. That photograph is Tottenham Court Road Station. So we were able to integrate all the existing physical infrastructure with the planned new infrastructure, and therefore imagine what were the challenges that were going to be faced as we built a new station in the centre of London. And to the right is an example of the carriage of a train that will run from London to Birmingham. And you can sit inside that model in an office in central London with your VR goggles, and you can see every bit of that journey from London to Birmingham. You can sit on a seat that gives you the sense of vibration and movement as you go along, and you can experience and test every one of the sound barriers and the experience that a passenger is going to have in that train in the future. So earlier they were saying, how do we imagine the future and experience it today so we know that we're building the right things for users? And I liked it at the end of this. The left is the early drawings that I did, but now we're printing elements. And these are optimized structural elements, only possible because of computing power and computational modeling. We would not be able to do that if we didn't have that in our tools. So today, and this is the transition, today we might model a building like this. So we are able to integrate the landscape design with the structure, with the seating of a stadium. And that waving that you see above that, that is an embedded CFD model of the air temperatures. And the problem we were trying to solve here was, how do you, in a Middle Eastern country, have footballers on a pitch at a lower temperature than is occurring outside the stadium? And the design of the roof was not for look and feel, but to achieve that temperature on the pitch. So that is the change in solving problems that I have sort of seen over my career. So I would say, why model? It helps us understand a system our interaction between systems. You know, we're not so unidisciplined, we're very I say multidiscipline, but I think in David's language that'll be multi-system. We're able to examine a wide range of scenarios, test hypotheses. Might this happen? Might that happen? Most importantly in my world is planning for success. I'm mostly involved with large infrastructure projects. My career has mostly been in aviation, so how do you successfully deliver a new airport and get it opened on time and successfully? Helps us understand human behavior. I think the human interaction with systems is becoming increasingly important. And we also want to know in the work that we do that we're delivering social value. Does it make the world a better place? Are we improving things for mankind? And along the journey, we have to get stakeholder engagement if something is going to be successful. And I picked this little line out of the report, I think written by Mark Wolport, is the alternative to the careful use of a good model is a non-examined future. And would we want to be there in a non-examined future? I suggest not. But I want to say a little bit more about the role of the Council for Science and Technology and how we work. I think I'm very privileged to be a member of that council, and we get to talk about some very challenging and interesting topics that affect our nation. What happens is we look forward and identify what are the key topics, and then members of the CST volunteer or choose to apply their expertise to help in a particular area. And myself and Rowan Douglas from Willis Tower Watson were the pair who initiated and started the work on computational modelling. I came from a built environment background, and Rowan came from the insurance industry. So he was more interested in the impact from environmental or climate change events. And what we did first to interest the CST in computational modelling was to raise awareness around that table, because that is a group of people from very different backgrounds with different experiences, and that's the value of the body. And so these are some slides, though a very small selection of slides we used at the time, but to make people aware that models could be very much about an individual and human interaction. Models could be multiple systems in the built environment, or they could be national or geographic, very large-scale complex models. And the level of accuracy and ability to predict varied with complexity, and that we might have to run more scenarios when we were uncertain about what the boundaries or the circumstances were. And we were also thinking at that time about challenges we were facing in the UK. There was healthcare, first of all. And so we tried to think what were the examples of modelling which we could find? So we're working as two individuals with support of the Secretariat. What were the models we could find to demonstrate to our committee or our council how modelling might be used? And here was one which was an example of modelling a heart and understanding how a heart behaved and how different medical procedures could be tested on this model. And so it mightn't be a perfect model, but it is a model of a heart. There was human and physical performance. So the one on the right was an example of a model of how people could test gait and see how they could understand physical problems and address those. And then there was a really interesting one we found from a company called Mastodon C, who had looked at the pattern of prescribing across the NHS. And they found in the patterns over an ability to find, they found overprescribing, and they felt if they could address that overprescribing, they could save 200 million in the NHS. Now, I can honestly say here today, I don't know if that was implemented, but the ability of understanding that would help with cost savings. Another area of interest at the time was about delivering major projects with certainty and knowing they'd work for the users. So here is an example of understanding people movement within a large metro station. In the past, we used to use criteria to design a building, which were based upon experience. And now we can actually test different events in a station. Here is people entering a building through security. Different characteristics are applied to the different colors of individuals. And so we can see what might happen. Here is a building, us analyzing what would happen in the case of a fire event. Would the exits really work? How quickly could we get the people out of the building? And that could be also utilized for other examples such as blast or security or things like that. And here's another example, like I talked about a stadium earlier. Here is an example of understanding the coming in and out of a stadium, and you can run different scenarios on that with different characteristics. So they were very much the sort of world that I work in, whereas Rowan worked in flood. And he was trying to understand how to insure across the UK, or in fact across the world. So he was considering a wide range of plausible events, understanding what the damage might be. And through their modelling, they were looking at sort of 1 in 200-year events. And he felt they calculated from this model that the annual aggregate was 6.7 billion. But that the worst events didn't necessarily produce the worst examples. So let me then move to, here is an example of an integrated flood model for the city of Leeds. Anyone from Leeds here, or that area? Have you seen this before? So this is an integrated model. So there is a 3D model of the city and its buildings. There is the landscape in this model. There is the river flood model. And there's also the city drainage, all in this model. Well, the important thing for me is that it is visualized. And therefore, one could talk with politicians, funders, neighbours, users about how did we alleviate the flooding in that city. And I think I have here in 2015, there was significant flooding. 672 commercial properties were affected. The direct cost to the city for that event was almost 37 million pounds, and the indirect cost to the wider city region was 500 million. So this flood, I'm just going to stop it for 2 seconds. So what happened is that there was a flood prevention scheme designed, which cost in excess of 100 million. The council said it is not possible for us to progress with this scheme. So what are the alternatives? And this model was a way of exploring what might the alternative scenarios be. And here is one little example. If I can get that to play again. So here's a part of the scheme at a particular site. And so you could look at, that is some flood barriers here. I think I've missed my little bit. Anyway, a range of scenarios were looked at, and a reduced cost scheme has been implemented on a 1 in 75-year event. And the scheme was used in full anger last weekend because there would have been a flood event in the city, except the weirs were dropped and they could analyse it. And what was really joyous for the team who worked in that was to send messages this week saying the model completely and accurately predicted the event, and the mitigation measures they put in place over the weekend to prevent flooding of the city worked. So I'm glad to be speaking this week because I can say we know that this absolutely worked in anger, and I think that shows the value of finding cost-effective solutions, answering the right question, and us being able to solve a problem. So I think we at the CST were really thinking about how can UK expertise in modelling transform our understanding of the grand challenges, and I gave you a few examples there. And I do genuinely believe, we can bring together complex information to yield insights. I think that Leeds model showed that. We can optimise solutions, we can plan scenarios, and most importantly, I think this has been said this morning, that working around a model really enables collaboration. People can talk about the model rather than talking about just their own focus, which might be cost saving or delivery or whatever. So I think it's an absolute enabler of collaboration. Complex ideas can be conveyed through these visualizations. And I think we can deliver projects with greater certainty. And I don't know if we think enough about how we create experiences for people. What I haven't shown here today is that modeling and visualization are very much used in areas for maintenance and access in complex and unsafe conditions, where people can plan their activities very carefully. An example of that might be repainting our maintenance on the old Forth Road crossing, where I know modelling has been used to enable the maintenance workers to plan ahead their activities and to have experienced working at height before they have to do that. So I think another great benefit. Now, moving to the Blackhat Report itself, I think it's been referred to earlier on. I think we came to a point in the work that Rowan and I were doing and realized we were just two people with two perspectives, and we definitely needed the involvement of a wider group of real experts, so thank you to all those who were involved. And we also realized that writing a letter to the Prime Minister with our recommendations was insufficient for such an important topic as this. So it was Mark Walport who suggested and pushed through the idea of doing a Blackhat report. And its purpose and what the report covers is, why do we model? Making and using models, different modeling techniques, the future of modeling, how it might help us. And then we thought that including case studies from various sectors would help people understand better what the power of modeling would be. And I have picked up some more examples here, some of which are in the report, some are not in the report, just to give a sense of how I, the advocate, would like to see models used. And in some cases, I'm going to let others speak for me, like in this model. So this is a concert hall north of the Arctic Circle.
I'm standing inside a computer model of the Great Hall at Stormen, a new cultural centre in Buda in the Arctic Circle of Norway. The brief was to provide a highly flexible space which could accommodate a wide range of performances, from drama to amplified music to orchestral performances. Arup worked with DRDH architects to achieve a highly innovative solution. The hall is currently in theatre mode, and the acoustics were designed to achieve excellent conditions for speech and drama and amplified music in the stalls, in the first balcony, and up in the second balcony. The room configuration and acoustics can be adapted by folding back the proscenium panels, by deploying some panels from above to seal off the fly tower, by flying in an orchestral reflector array to help the orchestra hear themselves, and by tracking in a series of 14-metre high panels. Of course, in orchestra mode, it's not best suited acoustically for speech, but let's take a listen to an orchestra.
I think about that example is it started with a how will we know what our concert hall will sound like? How do we know what that experience will be like? And it was a community project, so money was a constraint. And they wanted to know how do they get the best value out of the money they were going to spend, and how was that experience going to be? Through using the model, they realized, no, they didn't realize, they asked, what could this, when we're spending this amount of money, what could this hall be used for? And that model was used to explore the different settings they could use. So they now have it for drama, for music, for, I'm not using the right technical theatre words, but they got many more purposes out of the same building. They didn't know how to move all that equipment. And so that was to assure them that you could change from one mode of theatre to another mode. They also used VR goggles to experience what it would be like for an individual sitting in any place in that theatre in advance of them building it at all. So I think it's a good example of exploring options and getting the maximum out of that project in advance of starting to build. And David, they didn't know what the question was when they started, but they used the model to explore what question were they trying to answer and what were they trying to achieve. I think another one which I thought was quite a good London example is the New London electric taxi. And here is a pin, you may have even experienced that now, but here is an image of the model of that taxi and all the components that were in it. Of course, it had design criteria for safety of passengers, like any vehicle would have, safety of pedestrians. There was also lots of performance criteria. But I think the plus of this particular model was it was a single model with all those components brought together in one model. The analysis was done between two cities, London and Shanghai, so they could really compress the design program, so the efficiency of working in one time zone, passing the model to the other time zone, doing some other work and passing it back and forward, that continued throughout the process. So access to resourcing was really helpful. And there was absolute minimal crash test, dummy testing, and the computer model so accurately reflected the tests that they could know the performance of the vehicle from the model. So I think it makes great efficiencies to the design process and a certainty about the outcomes and performance of the taxi itself. So there's just a few examples, and I wanted to sort of reiterate David's message that, you know, the world is complex, and it is made up lots of interconnecting systems. And we are very clever and well-intentioned, but modeling can help the human really better understand the world and solve the problems. And I wonder, you know, when we look at these images, do we want to live in polluted, congested cities? No. We want to live in green cities where we can enjoy our lives. And I think that the power of computational modeling can really help us understand these issues and help us create a better planet for us all. Thank you.